So good morning, everyone. A warm welcome to all. On behalf of the Department of Mathematics at Wilson College, Autonomous Mumbai, I once again heartily welcome Lieutenant Prakash Sansare, sir, for his second session in this IIT JAM Mathematics lecture series organized under the DBT Star Strengthening Scheme. Sir is the head and assistant professor at the Department of Mathematics of BK Birla College, Kalyan, India. His areas of interest are in real analysis and partial differential equations. Sir is conducting sessions on functions of one variable in this series. So thank you for taking out your valuable time to share your expertise. I now invite Sir to start his. I
Yeah,
feel it's
thank you
good to
so much
introduce you.
for thank you so much. I hope my
Yes.
screen is visible. Yeah, is my screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you. Thank you so much. Maybe participant, I really don't know the level of understanding since it's an online mode. Uh, uh, though first session I had, but then it's difficult for me to understand whether you are really understanding a topic or maybe that's really doubtful. So I assume from the positive side, without loss of generality, I assume that you all are since you are from the different part of India and the very few have joined. That means you are really interested to mathematics and specifically for the IIT JAM. So assuming that you are getting what I have taught so far, this is the second session, and I have been given a session from the real analysis part that's in the syllabus. You must have the syllabi copy. So I'll be covering the topic from L hospital rule to fundamental theorem of calculus. So in last lecture, we have already covered with the fundamental theorem of calculus. We had done two theorems of fundamental integral of calculus, and we have even seen the applications and problem based on those fundamental theorem of calculus. And I had also shared the notes of those theorem, and I'm sure that you must have received on your WhatsApp channel or on your respective email of those notes. And now what we will be doing today is basically a topic named as a Taylor series and the L hospital rule. So we will be doing a small the theory part of it, and then we will solve the problem based on it. Let me clarify, my approach will be more on a problem solving session. Won't be doing the uh, proof and all. So we'll be only taking the theory. Theory means the statement of the theorem which we require, a standard result which we require to solve the problem solving. Let me clarify, this session will only motivate you for the problem solvings and all. Of course, when you write IIT JAM exams, you need much bigger hard work. Maybe this is just a maybe contribute 10 to 15% towards your preparation, but of course, this will definitely motivate you for the problem solving session. So let's begin with this. Here, what is Taylor's series? So this is basically the Taylor series of a function fx about a point A is given by f of x is equal to f of a plus f dash. Here dash, that means the derivative. F dash a, then x minus a, f double dash a upon 2 factorial x minus a square, f power 3a upon 3 factorial x minus a whole cube plus dot dot dot. See, writing this dot 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 is equally important. If you miss out this dot dot, that means you're writing, this is an infinite series, so that one should clarify, one should know. Well, so when a is equal to 0, then this series becomes a special series that is called as a Maclaurin series. Yeah, so what is definition of Maclaurin series? Basically, when you replace, when you find out Taylor series about 0, then the Taylor series becomes a Maclaurin series. And this is just a compact form of the above series. So what this is, f of x is equal to summation n goes from 0 to infinity fn, this nth derivative evaluated at 0 upon n factorial x power n. So here A is 0. If you replace A is equal to 0, you'll get this expansion. So I strongly suggest a student to kindly note down or maybe memorize this standard Maclaurin series. So Maclaurin series means basically these all are the Taylor series expansion only, but at x is equal to 0. Uh, so one can definitely get this expansion easily. So here my f of x is basically e power x, and uh, the point A is equal to 0. So if you find out this e power x, this expansion, you will basically end up with 1 plus x square by 2 factorial, x cube by 3 factorial, so on and so forth. So of course, one has already calculated this, so you can verify this. I'm not doing that right now, but I'm assuming that you will verify this all the formulas. At the same time, for tips to IIT preparation, I strongly recommend and suggest everyone to memorize or maybe to remember this standard. These are all are the standard formulas which one can remember, and this will definitely help you for the problem solving. So e power x is this formula, sin x is x minus x cube by 3 factorial. So of course one can write down this is summation x power n upon n factorial, where n goes from 0 to infinity. So this is compact form of the e power x. Similarly, sin x, one can write down this as a summation minus 1 power n, then x power 2n plus 2n minus 1 upon 2n minus 1 factorial, and you can go from n goes from 1 to infinity. So maybe this is possible, but then this formulas which I have boxed out is equally is very important. So we'll be solving maybe all the problems which I'll be solving right now here, they will be purely based on this formulas. Maybe the standard expansion. Okay, so then what is a remainder term in this? The remainder term is denoted by Rnx, and this has a form Fn n plus 1 at derivative evaluated at c upon n plus 1 factorial x minus a power n plus 1, where c is lies between the a and x. So maybe you can screenshot this. In upcoming problems, I'll be using these formulas. Okay, so the very first question is uh, approximate f of x under root 1 plus x about x is equal to 0, and it is said that up to third degree. That means you have to go up to the third power of x. So now here my f of x is equal to uh, under root of 1 plus x, which is same as 1 plus x power half, and your a is equal to 0. Right? So we already know the formulas. We have already seen here, or maybe the standard formula we require. Fn f of x is equal to n goes from 0 to infinity. Fn evaluated 0 upon n factorial x power n. Of course, here we have asked to do that only. Evaluate at x is equal to 0. So that means a is equal to 0. So what I need is basically, I know this f of x is equal to f of 0 plus x minus, yeah, so 0 clearly. X minus 0, then f dash at 0 plus x minus 0 whole square divided by 2 factorial f double dash at 0 plus x minus 0 whole cube upon 3 factorial f triple dash at 0 plus dot dot dot. Right? So now why I have since I need a third degree, so x power 3, I'll go up to x power 3. Now let's calculate what is f dash at 0, f double dash at 0. f triple dash at 0. So I need to find out now what is f dash at x first thing. So f dash at x is basically half 1 plus x power half minus 1 is minus half. And if I evaluate f dash at x is equal to 0, then I'll get f dash at 0, which is equal to half. Then I need to find out f double dash at x, which is minus 1 by 4, 1 plus x power minus half minus 1 is minus 3 by 2. This would imply f double dash at 0 is equal to, I'll substitute 0 here, x equal to 0, I'll get minus 1 by 4. And let me calculate now f triple dash at 0, f triple dash at x, which is equal to, now this is plus 3 by 8, 1 plus x power minus 5 upon 2. This would imply f triple dash at 0 is equal to 3 by 8. Now let's substitute this value in this formula. Let me call this formula as star. So if I substitute this value in star, what I'll get is as follows. So f of x is equal to, yeah, I also need to find out f at 0. So that can be easily calculated. F at 0 will be from under root of 1 plus 0. So it is 1. So f at 0 is 1 plus x times f dash at 0 is half plus x minus 0, that is x square, by 2 factorial is 2. F double dash at 0 is minus 1 by 4 plus x cube by 3 factorial is 6. And f triple dash at 0, we have calculated it as 3 by 8 plus dot dot. So finally, we can say that 1 plus, this is x by 2 minus x square by 8 plus x cube by 16 plus, yeah, I want only up to power 3. So I can say that, so Taylor series expansion of fx up to power 3. So instead of equal to now, I will have, or maybe, just a minute. This is basically approximately. So I'll get the expansion up to third degree is this.
Sir,
Yeah,
sir, in this question, we can also find by using binomial expansion. We will get the same result, I think so.
using binomial expansion.
Yes,
So,
one.
but then, so NCR here n is a fraction.
So 1 plus x to the power n. So n will be half.
So how will
So,
you find out NCR? NCR is defined when n is a
sir,
positive integer.
mm,
Yeah. So binomial expansion, you need NCR, NC1, NC2, NC3, right?
yes, sir.
So and your n should be to when you calculate NCR, your n should be
Integer.
positive integer. Yeah.
Yes, sir.
So
Sir,
well, is it okay?
Sir, I mean to say that the expansion of 1 plus x to the power half. So there is a formula like 1 plus x to the power n. That is 1 plus nx plus n into n minus 1 by 2 factorial x square.
Yes, sir, we can do that.
Yeah. Can you tell me what is, maybe we can have another 1 plus
X to the power n.
n is equal to
1 plus nx
Yeah.
Then n into n minus 1
N into n minus 1
divided
by
by 2
2.
factorial into x square.
Okay.
Then again plus n into n minus 1 into n minus 2 divided by 3 factorial and then
Mhm.
x cube. And
Okay.
it and the sequence like goes this way.
Okay. So now what is n here?
Half.
X by 2 plus half. It will be 1 by 8 x square plus, I think we'll get
So
the same
minus
one.
So there will
minus
be
1.
a negative sign before
So
minus 1 by 8.
half minus 1 minus it will be minus 1 by 8.
Minus 1 by 8. And then here you'll get the x cube. Yeah. So maybe. So this is also fine. Yeah. But then you need to know this formula, then expulsion. So basically this is Taylor series expansion only. How did you get this formula? So this is basically a Taylor series expansion, and we are interested to find out. So if you know this formula, it's very good. But now just to begin with, or maybe to understand the Taylor series in a better way, I had taken this example. Now you may ask the question, why I had taken this? Well, you can verify this formula with this Taylor expansion. That is one. And one another beautiful application of this, you can write down this expression in terms of polynomial. And this polynomial is very smooth polynomial. So 1 plus x by 2 minus x cube, x square by 8 plus x cube by 16. So on and so forth. Maybe we are interested only up to third degree. So hence I have truncated this Taylor at degree 3. Is this okay?
Yes, sir.
Okay. Maybe here is a detailed solution I have written in the LaTeX. So maybe this you can get it. Okay, so let's go to the another problem now. So the Taylor series expansion is very useful to one of the strong application of the Taylor series expansion is to find out the limit, evaluating the limit. So of course, as you already said that we may approach the same problem via another techniques also. So one can observe that the same problem, those who are already aware of the what is L hospital and all. So one can find out there are different many solution methods to solve the same problem. So maybe my target in this lectures will be to encounter a maximum problem using Taylor series expansion. So why Taylor series expansion? You will also realize that Taylor when you do using Taylor series expansion, even your task maybe the calculation goes much faster than your traditional way of calculating. So let's see this, what is Taylor series expansion. So evaluate limit x goes to 0, 1 minus cos x upon x raised to 4. So I already know that formula for cos x, which we already written on the first page. So here I have written it. So cos x is 1 minus x square by 2 factorial, x raised to 4 by 4 factorial, so on and so forth. So it is 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus so on and so forth. So if I take this 1 to this side, then it will be 1 minus cos x. So I also need to minus multiply. Oh yeah. So it will be x square by 2 factorial minus x raised to 4 upon 4 factorial plus dot dot. Now, since x approaches to 0, that means x is never takes the value 0. So you can divide this expression by x power 4. So you'll get 1 minus cos x divided by x power 4 is equal to, this will be 1 upon x square into 2 factorial minus x power 4 upon 4. So it is 1 upon 4 factorial plus dot dot dot. And now I need to find out limit. Now you could see that this part is basically 1 upon x square by into 2 factorial minus 1 upon 4 factorial, so on and so forth. So take limit on the both side. So limit as x approaches to 0, 1 minus cos x upon x power 4. Now you could see that here dot dot dot, these all are the, in every terms x is present. So they are purely the terms of x. So when I substitute x is equal to 0, this part will be straight away 0. This is minus 1 by 4 factorial. And I need to find out limit as x approaches to 0, 1 upon x square. And this 1 by 2 factorial you may write down at the outside. Now this is equivalent to saying that 1 upon 2 factorial. What is limit of 1 upon x square as x approaches to 0? What is 1
Goes,
upon x square? What is limit
it
of this?
it goes to tends to infinity.
Infinity.
Yeah, it tends to infinity, and infinity minus 1 upon factorial, or maybe whatever it may be. So it final answer is infinity. So limit of this does not exist. DNE stands for does not exist. Okay. So maybe you can see that cos x, this. So 1 minus cos x divided by 4, 1 upon 2x square. So you take limit on both sides. So final answer does not exist. Is this okay?
Yes, sir.
Yes,
Yeah.
sir.
Now this is the your jam type question. Evaluate limit x goes to 0, tan x minus sin x upon x power 3. So what is your intuition? So of course in jam you need not means you should always have 100% accuracy. You cannot give a guess. When you write the jam exam, it's my strong advice is do not guess, because of course you have a negative marking in the session A. So you should not give a guess. But now here I'm just asking, maybe if you can what is your intuition to this? There are 4 options. A is equal to 0, B equal to half, C is equal to.
Sir, we can maybe put tan x
Hmm.
equals sin x, because as x tends to 0, as x becomes very small, it becomes almost equal to x, similar to
Hmm.
sin x.
There.
Then maybe manipulate something.
Okay.
Sir,
Uh,
Sir, here as x tends to 0, so in the
hmm.
expansion of tan x and sin x, the least degree term will dominate. So we can use the tan x expansion and sin x expansion. Then we
Hmm.
will we will calculate
Yeah,
the terms
that's a very
directly.
good, clever option, the clever choice. So maybe since we are working with the Taylor series expansion, we can use the tan x expansion. So maybe I have not written tan x expansion, but do you know what is tan x expansion?
Yes, sir.
Yeah. So it is basically,
X
yeah. Can
minus
you tell me?
x cube by 3.
Is it x minus or x plus?
Sorry, sir. I think x minus.
Yeah, you can cross
Plus,
check this.
okay. Then
2
2
by
by 15
50.
x to
Yeah,
the
x
power
plus
3.
5
And
plus
7.
dot dot dot. And similarly, you have a sin x also, which is yeah, maybe I have not written this. My advice is, student, please remember this formula also. So sin x is x minus x cube by 3 factorial plus x raised to 5 upon 5 factorial minus dot dot dot. So I need to have a subtraction of this 2. So tan x minus sin x will be, say x will get cancelled, so it will be x cube by 3, this minus minus become plus, x cube by plus 3 factorial. Now here again it's a dot dot dot. So here I will purely have a terms of x. So I'm not writing that. So what is this addition? This is basically 3 factorial is 6. So I may write down this is 6. So it is basically, you can multiply 2 here and here. So it is 3 times x cube upon 6 plus here the terms of x. And this is basically 1 by 2 plus. So I have x cube. So tan x minus sin x is this. Now I'll divide by x cube since x is not equal to 0. So tan x minus sin x upon x cube will be half plus dot dot. Now here you will see that there's a purely terms of or maybe power of x, positive power of x. And when you take limit as x approaches to 0, you will have tan x minus sin x upon x cube. This is a constant, so limit of constant is as it is. And here positive power of x will definitely give you leads to 0. So at last you can see that the answer to this is half. Do I have the option half? Yeah, so it's a B option.
So we can do this by L'Hospital rule also.
Yeah, how can you do? Yeah, I'm just asking that
So
if
we
you're aware.
will
But do
we
you
will
think that
differentiate
will
both
it be
limits
easy
and
if you go by the Hospital rule?
mm,
How many times you have to differentiate? Is the power,
so
you can see that here x cube. So from
yes,
this you can
three
3
times.
times, and
Yes.
the derivative will also be very difficult. First time tan x ka derivative is x square x. Second time when you go for the derivative, it is 2 times sec x into sec x ka derivative, that is sec x tan x.
Yes, sir.
And then again you have to, so u into v rule. So maybe little complicated. And for the IIT job, it is always advisable to have the short, no, means the methods, you have a time constraint. So this Taylor, of course you can get it through the L hospital rule, I'm not denying that, but if you apply the Taylor series expansion knowledge, I'm sure that it won't take more than 1 minute to answer this. Is this okay?
Yes, sir.
Yeah, thank you. So this is, yeah, maybe here you can see that
Sir,
I have
1 second.
yeah.
Sir, can we here typically apply a hospital rule because of are the condition of this hospital rule apply here? Because I think don't we cannot apply here because XSQ its derivative would 3x square and tending to 0 it is goes to 0, and in the hospital condition the fx by gx g dot x must not be 0 in the related domain.
No, will you wait for some time? Because at last I have
Okay,
given the
okay, okay,
condition for the hospital rule.
okay,
Well,
okay, okay.
I'll definitely answer your question. Yeah. So maybe it is 0 by 0 indeterminate form, and then you can go with the L hospital rule. It is possible. That is only I can say right now. But then, of course, what somebody has said, whether I can go with the L hospital rule, I will only suggest if you go with the L hospital rule, it will only take you a time. You may end up at last, but then it will take you a lot of time to answer this. Okay, so I'll go ahead. My next question is, so you get the answer also here. So B answer. Evaluate limit x goes to 0, e power sin x minus 1 upon x. And here are the 4 options.
Sir, B option is correct.
B option is correct. Okay. Can you justify?
Sir, expand. Oh no, sorry, sir. Actually, I think so. It is e raised to the power x. So I guess it is B. It is sin x. So it
Okay.
may be different.
Okay. Okay. E power sin x. So well, I know the expansion of e power x. It is, what is it? We have already written it. So it is
1
1 plus
1
x
plus
plus x squared by 2 factorial plus x cubed by 3 factorial, so on and so forth. Right now, instead of x, I'll put sin x. So e power sin x is equal to 1 plus sin x plus sin square x upon 2 factorial plus sin cube x upon 3 factorial plus dot dot dot. Now I'll shift this 1 to this side. E power sin x minus 1 is basically sin x plus sin square x by 2 factorial plus sin cube x upon 3 factorial plus dot dot dot. And now what I have to do after this? Can you guess?
divide
we
I
by
need to
do after-
divide by x.
Very good. E raised to sin x minus 1 upon x is sin x upon x plus this is 1 by 2 factorial sin square x upon x plus dot dot dot. Now I'll take limit on both sides. So limit x approaches to 0, e power sin x minus 1 upon x will be limit as x approaches to 0, sin x upon x plus 1 upon 2 factorial. This is limit of x approaches to 0. Sin square is basically sin x into sin x. So you may write down limit of a into b is same as limit a into limit b. So limit x approaches to 0. Now here sin x plus x, right, plus. Now I wanted to write here something, but then now you can identify. This is a very standard result. What is limit as x approaches to 0 sin x upon x?
1.
1, right, plus now limit as x approaches to 0. Here I have written sin x. Here it will be 1, but when x approaches to 0, it will be 0 only. Can you see that? Sin
Yes,
0 is
sir.
0. Similarly, here I will have limit x goes to 0 sin square x into sin x upon x, and that will also give you 0. So this term onwards, you will have always 0. Or maybe. See, all limits are basically 0. I need not have to worry. So only first term will be survive, and that will give you answer as 1. So limit of sin x upon e power sin x minus 1 upon x as x approaches to 0 will be 1. Maybe whoever has answered by mistakenly he has observed it's a x, but it turned out to be correct answer. So it is 1 sin x. Is it okay?
yes, sir.
Yes, sir.
So
You
where
can see here.
sir,
Yeah, maybe here you may apply the L hospital rule and you'll get it. That is okay. That's fine. So you may get some alternate answer is always possible. Yeah, that is what you are going to say, right?
yes, sir. It is I think this
Yeah,
solution.
yeah. We'll see that whether it is better or not. Just give me some time. Is this okay? Okay. Now the next question, the Taylor expansion of ln cos x about x is equal to 0. So now here my f of x is equal to ln cos x. Okay. So maybe I have. I know that we know that WKT stands for, we know that cos x is equal to 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus 1 and so on. Right. So what I'll do, this cos x can be written as 1 plus y. What I'll do is here, this term, I'll consider it as y. So where y is equal to minus x square by 2 factorial plus x raised to 4 upon 4 factorial minus so on and so on. Right, so what did I get is cos x is equal to 1 plus y. I need to find out ln cos x, the derivative, the Taylor series expansion of ln cos x and up to 4 degree. So I'll take ln on both sides. So ln of cos x is equal to ln of 1 plus y. And we know the expansion, a standard expansion of ln of 1 plus y. I think I have written here. One very first. ln of 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus so on and so forth. So let's apply that here. So assuming that mod x is less than 1, so here mod y less than 1. So it will be y minus y square by 2 plus y cube by 3 minus so on and so forth. Now what is y? Y is this. And I'm interested up to 4 degrees. Yes, said it is 4 degree. So we will only consider first two term, because third terms onward, they all are the degree 6 and onwards. So we are not interested in that. So here y is minus x square by 2 factorial minus 1 upon 2. Now y is basically this. So minus x square by 2 factorial plus x raised to 4 upon 4 factorial whole square. Now y cube will definitely give the terms, will have the terms of degree more than 4, so that we will not consider, or maybe I will not write here, because in a question it is clearly asked to find out up to degree 4. Okay, so this is further minus x square by 2 factorial is 2 minus 1 by 2. Now what is the square of this? This is basically
x to the power 4 by 4. And then again, this will maybe I had missed out one term here. What term I have written here? Y is minus x square by 2 factorial plus that I did not write. Maybe right. So it is same as minus x square by 2 factorial here plus x raised to 4 upon 4 factorial. So this y I have written here. Then minus 1 by 2, y square is this. Okay. Now this is equal to minus x square by 2 factorial. Now this is plus x raised to 4 by 4 minus half. Now here x raised to 4 by 4, I have to take it, because this term onwards it is basically the power 4 and above, so that I will not consider. So this is equal to minus x square by 2 factorial
plus here 4 factorial it is. So x power 4, 4 factorial is 24 minus x power 4 upon 8 plus dot dot dot. Right. So at last I'll have ln of cos x is approximately up to 4 degree. It is minus x square by 2 factorial. So maybe here I may need to multiply by 3 here and 3 here. So 1 minus 3 will be minus 2 times x power 4 upon 24, which is equal to x minus x square by 2 factorial is 2 minus x raised to 4 upon 2 by 24 is 12. So the answer is, this is my answer. So minus x square by 2 minus x raised to 4 by 12. Let's see whether this is there or not. Yeah, I think it's mentioned. It's option A.
Sir,
Yeah, please.
sir, here log 1 plus y. How do you know about the mod of y is less than 1?
How do I know about mod y less than 1? Okay.
If you know, then we can apply log 1 plus y equal to the
Yeah,
series.
can anybody here can guarantee that mod y is less than 1? It's a good question. How do I know that why mod y is less than 1? If this is true, then only I can then only I can go ahead. So now here I have assumed that mod y is strictly less than 1, because in this formula, where is this? We apply this formula only if mod x is less than 1. Yeah, it's a good question. What's your name? May I ask?
Sir, Akash Raj.
Yeah, Akash. It's a good question. Akash, can you think over it? We'll answer you back. So this question we will definitely answer. It's our answer so far. So we'll take some time, and you also think it. Maybe tomorrow also we have a session. I'll try to answer this.
Sir, I am thinking in this question that cos x equal to 1 plus y.
Cos x
And equal to 1 plus. Then we can shift cos x minus 1 equal to y.
cos x minus 1 is equal to y. Okay. And what is the
Then I
maximum
think
value of cos x?
is 1, sir.
Yeah. So can I say that then mod y is always less than 1?
Sir, it is less than or equal to 1.
But I am here strictly subtracting 1. Cos x is less than equal to 1. Mod of cos x. And now when I am saying mod of cos x minus 1 will be less than equal to 0, which is strictly less than 1.
Yes, I'm just thinking.
I think it's very clear. Do you really need an explanation for this?
No,
In
sir,
fact, you
nothing.
have only answered. Cos x is equal to 1 plus y. So cos x minus 1 is equal to y. And cos x will take maximum value as 1. So modulus of this cos x minus 1 will be equal to mod y. And this modulus will be definitely less than equal to 1.
Yes. I think my thinking is maybe wrong or right. Therefore, I don't know about this.
Yeah, it's correct. It's correct. It's correct. That is what I'm saying. So what you have thought is correct. So that's a, in fact, and correct justification why mod y is less than 1. Is it
Okay,
okay?
sir.
Okay,
Yes,
we'll
sir.
go ahead. Maybe here is a compact answer I have written. Now this question number 6, fx is equal to 1 plus x square. What is Maclaurin series up to 4? What is Maclaurin series? Can anybody quickly tell me?
If we evaluate Taylor series about x equal to 0, then it is
Very
called
good.
Maclaurin series.
Very good. Very good. And I know that 1 upon 1 minus x has a formula. This is
1 plus x
x
plus
plus
x square
x square plus,
plus x cube plus dot dot.
right? So now what you will do, you will, instead of minus x, what I want here, x square. So put or replace minus x by x square in this. So what I, or maybe minus, or maybe x by
X by minus x square.
x by minus x square, right? So what you'll get it? So 1 upon 1 plus x square will be 1. Now x by minus x square, you'll get minus x square plus your minus x square. So it is minus x square whole square, and you need up to degree 4 only. So this is equal to 1 minus x square plus x raised to 4. I think option, or maybe the option A is correct. Is this okay? Now the next question is limit x goes to 0, e power x square minus cos x. Now I know that what is e power x? It is 1 plus x square by 2 factorial plus so on and so forth. So what will be the e power x square? You will replace x by x square. So 1 plus x square plus x power 4 upon 4 factorial upon 2 factorial plus dot dot dot. And we also know what is cos x. Cos x is 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus so on and so. So if I subtract this two expression, what I'll get? E power x square minus cos x is equal to this 1 and 1 will get cancelled. So x square minus minus plus x square by 2 factorial plus here terms of x. Now this will be 3 by 2 times x square plus the terms of x, and now I need to divide it by x square. So e power x square minus cos x upon x square will be 3 by 2 plus, now here terms of x, and they will be definitely, every terms will have a positive term of x, and when you will take the limit as x approaches to 0, limit as x approaches to 0, e power x square minus cos x upon x square will give you the answer 3 by 2. Is this okay?
Yes, sir.
Yes, sir.
And now you can see the beauty of this. If you go with the L hospital rule, it is really very difficult to find out this. You won't end up with the proper answer. You'll have a lot of complicated, means maybe it's difficult. It's almost impossible to go via L hospital rule. But with the help of Taylor series expansion, you can easily find out this answer. You only need to know the expansion of e power x cos x and just have a substitution. You can easily get the answer. Maybe I have 3 minutes more to go. I'll just 3 by 2. So this question I won't be taking ln of 1 plus x minus x because I have already written a solution here. Yeah, this is a standard formula and then you just shift it and you'll get this answer. Now let me cover within what is L hospital rule is used to evaluate limits that results in indeterminate form as such. 0 by 0, infinity by infinity. These all are called as a indeterminate form. And somebody has asked me that in L hospital rule you need denominator to be zero, non-zero. But let me state that statement. Let fx and gx be differentiable at a, and suppose limit x approaches to fx is equal to 0 or infinity, gx also 0 or infinity, then this limit is basically evaluating this limit is equivalent to find out the derivative first and then take the limit. So provided the limit on the right hand side exists. Of course, this assumption one needs to think of. Okay. Applicable indeterminate form 0 by 0, infinity by infinity. 0 into infinity is also called as an indeterminate form. You may convert this into 0 infinity. You may write it as 1 upon infinity. So it is again 1 upon 0. Then infinity minus infinity. You can use algebraic manipulation to get this. 0 power 0, infinity power 0, 1 power 0. Take the logarithmic and convert into the indeterminate form. So important note, apply only when the limit is indeterminate. So do not apply L hospital rule when the limit is determined. So it is only evaluate if it is indeterminate form. Agar indeterminate form nahi hai, to you cannot apply the L hospital rule. Function must be differentiable. That's very important. May require multiple applications, and sometimes Taylor expansion is more efficient than the L hospital rule. So here is quick example, e power x minus 1. Now here you can see that my fx is e power x minus 1 minus x, and my gx is x square. So you can find out f at 0. F
One
at
with
0
the
will, sorry, it is 1 minus 1, it is 0. So f at 0 is 0, g of 0 is 0. So it is 0 by 0 indeterminate form. So the L hospital rule, if you apply, the L hospital says that you find the derivative of numerator. E power x derivative is e power x, minus 1 derivative is 0, x derivative is minus 1 upon 2x. Denominator derivative is 2x. Now you need to find out this. Now again, when you substitute x is equal to 0, e power 0 is 1, 1 minus 1 is 0, and denominator is also 0. So it is indeterminate form. Again apply L hospital rule as limit x approaches to 0. E power x derivative is e power x, minus 1 derivative is 0, and 2x derivative is 2. Now you substitute x is equal to 0, you will get e power 0 upon 2. E power 0 is 1, 1 upon 2. So the answer is half. Is it okay? Maybe I
Yes,
have
sir.
written, answers. I have not written detailed answer here. Maybe this time I will save this file with this, and so I will share. So you will not get answer. Straight away I have written half. Similarly, ln x, so it's 0, you can say. Why I have written 0 positive? Can you answer?
yes, sir. Ln is
Negative
not
for the
defined for the
undefined.
Yeah, ln is not defined for the negative x, because if you draw the graph of ln x, this is ln x. So this is 1. So as x approaches to, you can also observe that ln between 0 to 1 is always negative. Right. So that's a very, because graph in the fourth quadrant, and in fourth quadrant output is negative. So now this is 0 into this ln 0 does not define. So 0 into infinity form. So you can write down this as limit x approaches to 0. Now I am assuming that it is 0 positive. So ln x and x can be written as 1 by x. So this is infinity upon 1 by 0 is infinity. So it is infinity upon infinity form. Use L'Hospital rule. So L'Hospital rule is ln x derivative is 1 by x. 1 by x derivative is minus 1 by x square. And this will give you limit x approaches to 0 positive minus x, and this limit is straight away 0. So using using L'Hospital rule, we can say that the limit is 0. The answer is 0. So maybe this was problem number 9, 10, maybe 11th one. This is again use L'Hospital rule. I'm sure that you will easily get it because here x derivative, it is 0 by 0 form. 0 sin 0 is 0, x cube 0. So its first derivative is 1 minus cos x upon 3x square. X approaches to 0. Again, when you replace 0, so cos 0 is 1. So 1 minus 1, 0. So 0 by 0. Have one more time L'Hospital rule. So numerator derivative is 1 minus 0 minus cos x derivative is minus sin x. So it will be plus sin x upon 6x. Again, this is 0 by 0 when you substitute this. Again, apply the L'Hospital rule. So limit x approaches to 0. Sin x derivative is cos x upon 6. And cos 0 is 1, 1 by 6. So the final answer is 1 by 6. Okay, so maybe that's it for the today's session. We have tried to cover some little part of Taylor series and your L'Hospital problems. So maybe in next lecture we'll try to cover the further topic which I have assigned to me, maybe maxima, minima, and that's Riemann integration. These two topics are left out. So I'll try to cover in next lecture both this four remaining two topics.
Sir,
Yeah, please.
so in seventh problem, so please open the seventh problem.
Okay.
I think, sir, we can use L'Hospital rules in, I think, in one step, and we can get
How?
answer.
How?
So if you differentiate, we get e raised to x square times 2x plus sin x divided by 2x, and separate 2x in both sides. We get 1 plus
Okay.
half.
Just let me write down this. If you could get it, it's very good. It is e to
Yes, sir, we can do this.
x square into 2x minus it is sin x upon x square. Now
So we will separate each term.
if I separate this each term, what will happen?
So in the
2 times.
denominator, twice x.
Oh, yeah, this 46. Okay. So, yeah. Sin x upon x. Yeah, you'll get this is 1. So this is half and maybe, yeah, correct. Half plus 1, 1 plus half, which is equal to 3 by 2. Good. Yeah. Yeah, you're right. You can use the L'Hospital rule and you can get the answer, which will be, that's an alternate solution. This is also an easy solution. Anything else? But it is observed that many a times L'Hospital rule, Taylor series expansion gives, for example, I just opened this problem. Yeah, this this expansion. So maybe if you have a problem where limit of ln cos x and all comes, where you can definitely use this trick, or maybe let's see one more problem where Taylor series has played an important role. So this one, tan x minus sin x. Can you see that if you go with the L hospital rule, your calculation will go little lengthy, or
Yes,
maybe
sir.
using Taylor expansion you will get faster answer than the L hospital rule.
Yes, if derivative is difficult, then
It's not that the comparing this, I will, in fact, I'll quote here during the examination. If you find it, L hospital is much convenient, and if you get it in a 1 or 2 stroke easily, then you can definitely go with the L hospital. But if as soon as you come to know that it's well, you are going into the loop when you apply the L hospital rule. So the best way, immediately come out from the L hospital rule and go to the Taylor series expansion. I'm sure that you will approach to the answer much faster than the Taylor L hospital. That is what my suggestion. Note of advice here. Yeah, any question apart from this? So another half minute I will wait. If there is any question, I can take it. Otherwise, I'll hand over the mic to the organizer. Okay. So thank you so much. Maybe I don't know whether I can only say that this sessions will only motivate you towards the problem solving. This will definitely help you, but then if you really are interested for IITs and all, you have to work out in depth. This will only beginning towards your preparations. So thank you and all the best for your preparation.
thank you, sir.
Thank you, sir.
Thank you, sir, and thank you, participants, for joining this session. We will have sir's next session on 30th October, and the timing will be the same. So thank you. Have a good day. Thank you, Prakash sir.
Yeah, thank you, ma'am. Thank you.